Waves travel along a stretch stroke. The vertical distance from crest to trough is 17 centimeters, and the horizontal distance from crest to trough is 23 centimeters. The frequency of the wave is 0.55 hertz. What is the wavelength and the amplitude of this wave? Alright, so let's have a look at this. If we have a wave, okay, albeit not a very good one right there, and I have my equilibrium point that goes across in red. Alright, we have two pieces of information. The crest to trough, the horizontal distance, so if I go from here to here, this is 17 centimeters. And then we have crest to trough would be, vertical distance would be here to here, 23 centimeters. Okay, so they're asking for two things here. They're asking for what the wavelength is. So the wavelength is one full cycle, or from crest to crest, or from trough to trough. So if we know the distance is 17 centimeters from crest to trough, we then know the distance from crest to crest has to be essentially 17 centimeters times 2. So the wavelength for part A is going to be 34 centimeters. And then the amplitude is the maximum displacement from the equilibrium point. So the amplitude here is going to be 11.5 centimeters. Because if 23 is from crest to trough, we know then the amplitude is that distance from the equilibrium point. So the amplitude will be half of the 23. Plot the wave on a displacement versus time graph. Alright, here the frequency is going to be important. And this is because we need to figure out the period as to when whole cycle occurs. So if the frequency is half a hertz, we know the period is equal to the inverse of half of the frequency, which would be 2 seconds. So for every 2 seconds, it's going to complete one cycle. Alright, so if we start here, we'll end up with one whole cycle as it goes through 2 seconds. We'll end up with 2 whole cycles as it goes through 4. Right. So our wave is going to look something like this. Alright, to determine the wave speed, we can use wavelength divided by the period, or wavelength times the frequency. Either way, we're going to end up with the same answer. So it's going to be 0.34 meters times 2 hertz, or 0.68 meters per second.